Hello creators, hello to our 6 Creators Lounge, hello to everybody here in Graz at AVL's headquarters and also to everybody streaming live online, joining us for a very interesting topic today. We're gonna talk about industrial energy transition and how that can change our own innovation attempts. For all of that, we wanna welcome a very great host that will guide us through the program today. She's one of the communicators of our industry, a vibrant networker. Hello, Ludmilla Derr. Thank you for being with us, and over to you to lead the day.
Thank you very much, Sebastian, for this kind introduction. Good morning. Good morning to our live audience. Good morning to our digital audience. And good morning to everyone who is going to listen to this panel discussion in the recorded version. Yeah, today's question is, will industrial energy transition spark a new era of innovation? That is the main question for today. Because yes, we are in the times of transition, and whenever we are in the time of transition, we have the chance to change something, to foster innovation, to put sustainability at the forefront. And today we are joined by 3 amazing speakers. Actually, it was planned to have 4 speakers, but unfortunately, to some illness, we have spontaneously to change our setup. However, we are today in the setup of 3 amazing speakers who I would love to introduce to you. So let's get started with Christian Leitner as business leader, future mobility at Rockwell Automation. And we have Philipp Irschik as Vice President, Strategy and Business Development and Sustainability at Energie Steiermark. And we have a home match, let's say, with Matthias Dank as Executive Vice President, Global Business Development Sales in International Operations in the Instrumentation and Test Systems Division at AVL. What a title, right? So, apparently, as I said, we are in the times of transition. But before we start asking the question, what's next? I would love to ask you, based on your current expertise and your field of business, etc., what is actually now? So, Christian, would you like to start? What is now?
So first of all, pleasure to be here. Hello, everybody. So I would say there is a lot of good things going on at the moment. So in particular, if we look at my field of expertise, which is automotive, so I think by now, really everybody has noticed a certain change in the automotive industry, right? And that is the shift from internal combustion engines to battery-powered so-called electric vehicles, right? I mean, if we look back a little bit, on the one hand side, this has basically been enabled or has also been driven by very innovative startup companies, as we all know. But I think more importantly, and also more recently, it's also very much driven by governmental regulations. So, for example, if we look at Europe, at the European Union, they have made a very bold decision and voted to ban all car sales of new internal combustion engine by 2035. And I think this is really a remarkable decision here. And it's exactly those new regulations that are coming up for the industry that is now driving extremely high investments from the industry. I would even go that far to say never seen before investments in the automotive industry of the 100-year history here of the automotive industry. And just to keep up with those new regulations. And apart from, it's just more than just swapping out the existing powertrain of a vehicle. It's really everything across the supply chain is changing. So it's changing the way how we design and how we build vehicles. It's changing the entire manufacturing process. It's changing the technologies that we use. And even more important, it's also changing the needed workforce, the needed skills. So it's also influencing the actual people that operate the equipment, that work with the new technologies. So those are all very important things. Apart from that, I mean, it's clear that there is a huge demand of batteries to power all those electric vehicles. And we're also seeing dozens of new, let's say, battery gigafactories currently under construction in Europe. That's predominantly investment from existing battery cell makers coming from Asia Pacific, expanding into the European market, also North America, etc. But of course, there is also plenty of new startup companies with very new innovative ideas to come up, to improve batteries in general, increase the adoption rate. And last but not least, there is of course also the automotive industry, the incumbent car makers, the big brands that now finally also have realized, wow, this is a critical piece of equipment that goes into our car. So we have to vertically integrate the battery also into our production environment. I mean, I was just talking about cars now, vehicles, because that's my main topic. But of course, it's much more, right? It's an entire concept that is changing now. So I mean, there is multi-billion-dollar investments, for example, in the public transport sector. So I'm thinking about railway, and I'm also thinking about greener development projects in urban areas and cities.
Thank you very much for this overview. And actually, because you emphasized regulation, we will definitely come to that topic because, Philipp, you have so much to do with regulation. You will have a word or two to say about that, definitely. So we will come to that. And actually, yes, electrification, I mean, where does the energy comes from? No? So that is all very, very well connected. So therefore, let's continue the discussion. Matthias, what is your status quo, let's say, that you observe in the energy, industrial energy particularly?
Thank you, Ludmilla. So maybe let me try to look at it from a little bit a different angle. I think we are at the moment of realization, and we have realized, and on that terms of society or mankind, I think we have now agreed to global warming is a thing. Greenhouse gases are a problem, and if we want to be sustainable in all of that and we don't want the climate to further escalate, we need net zero. We're still in the discussion of when that is going to be, ideally tomorrow, but tomorrow is not feasible, so how can we get there? And I think at the same time we've also realized, you brought up the good point of electrification. It has spawned massive investments in the industry towards electrification. And if we just take a look back in the early 2010s, the first pure battery electric cars on the road were the Nissan Leafs, the Renault Zoes, the BMW i3s. If we take a look now, a little bit more than 1 decade later, this has massively changed. At the same time, we have realized that it will most likely not be the only answer, because all of the other questions came up. How do we get all the electric energy? How do we transmit it? Where's the grid requirements? If we now scale it all up, what are the production volumes? What do we do with legacy? And you mentioned regulations and banning. That was a huge decisive factor for spawning that innovation. At the same time, what we see specifically in Europe, legislators now started to ban a technology, and that's kind of a first thing. So personally, I'm a friend of politicians to tell us where we need to be. So what is the desired outcome? But as an engineer or engineering organization, please don't tell me how to get there and what to do on that way, because that's pretty much our job. So by banning technologies, on the one side, you are limiting options, and at the same time, you're giving the industry the big question on what are new technologies that are to be banned? How safe is my long-term investment? Because we're talking about massive investments in all of that.
Actually, very nice that you say, okay, we should broaden the scope of technologies, let's say, no? So, and try not to ban too fast. No? So, but maybe to incentivize, let's say, some technologies that you want to push. No? So
positively technologies, incentivize a positive outcome, tell us where to go, because engineers are brilliant and super creative, and they can, well, if they are left to their own devices, they'll think about anything. If you give them a direction, they also move with the technology in the direction that they go. And if you think about, let's take the example of the past 30 years of emission legislation. There was constantly being driven downwards. The automotive industry achieved to stay always below the limits when they came, but at the same time, cars got better, more comfortable, safer, managed to get more infotainment. So all the other targets got at the same time. So tell us where to go and not how to get there.
Thank you very much. And now I'm looking always at Philipp, and he's already smiling so well. No? So I mean, okay, tell us, what is your status quo? And I hope it's so positive as you look like here.
I think Matthias already touched on several very important points. Actually, the energy transition has been going on for quite a time already, and not only in Austria, not only in Europe, but all over the world. What we see are massive tectonic shifts that are occurring. We see that we have key trends made up by decarbonization, decentralization of the energy supply, and also the digitalization of the system. And now, after maybe 10, 15 years of this ongoing transition, which is increasing in speed, we see that it's getting more and more complex in a systemic way. And in the energy sector, we normally approach issues in a triangle sense, that we look at it from what does it mean for the affordability of energy, what does it mean in terms of sustainable energy supply, and what are the repercussions in terms of reliability. So in the past, we had a very reliable, pretty affordable system. So we very much focused, energy companies, but especially politics, regulation, society very much focused on the issue of how can we make this working system more sustainable by introducing renewable energy sources, decentralized energy sources, such as PV, wind farms, etc. What we see nowadays is that in the past maybe 2 years, due to the global environment, the political environment, the crises all over the world, the issue of affordability and security of supply has moved more into the center of attention. Like 1.5 years ago, due to the conflict in Ukraine and Russia, we had the issue of everyone was afraid that they don't have sufficient energy for heating during winter times, or industry in order to continue producing energy-intensive products. And at the same time, we have the issue of affordability. How do we finance all those very important but very substantial investments into power generation, into grids, into flexibility, into storage, into e-mobility, into electrification in general, and at the same time keep it affordable for households and industry and remain competitive in comparison to other world regions. So I think that's the current situation. And then Matthias already rightly jumped to the issue of either what does it mean in terms of technology, and also what does it mean in terms of politics, regulation. Is it fostering, is it driving this transition, or is it sometimes also hampering this transition?
Also very nice that you mentioned just slightly digitalization, because we will come to that as well. So, and the complexity of the system that it gets, because like 10 years ago, you had completely different issues, let's say, than you have now. And we have the right man here sitting with the strategy and business development in that field, so we will definitely come to that. But let's now get technical. As you mentioned, like, okay, let's make the cycle. So, Christian, when we talk about the technological possibilities that are currently available now, so if you could discuss what kind of solutions do you see that are available now, and if you can rate them, let's say, based on sustainability and efficiency. So make it technical. We have technical audience.
Good. I will try to make it a little bit technical. I'm also not super technical, but hopefully technical enough. So if we stay again a little bit in this automotive EV battery context, maybe I can give you 3 different examples. So perhaps we can start, at product level, then perhaps manufacturing process level, and last but not least, supply chain. So if you start with the product, I mentioned before, the battery in those new vehicles and that new technology is the most critical, most important piece of equipment that powers basically the car. It's defining the cost, it's defining the performance, it's defining everything. Also, the adoption rate, of course, is highly depending on the performance of the battery. So it's no surprise that there is currently a lot of investments, a lot of innovations from research and development, and there is, let's say, different approaches. So I would say that the standard approach is just taking a standard lithium-ion cell, as it was always made in the past decades, and trying to optimize those cells. So that could either be achieved by new cell designs, by optimizing the chemistries that go into those batteries, I think Tesla has, with introduction of this 4680 cells, has shown, how that actually could work, to improve certain parameters such, like range, energy density, cycle times, enabling super fast charging, all those things that actually matter for the adoption rate of the product. But then, of course, there is the next generation of batteries. So for me, that would be, for example, solid-state batteries, where you basically replace the liquid electrolyte by some ceramics or some other solid materials. And then there is even more innovative approaches, more innovative attempts from all kinds of different academia and startup companies to replace certain materials to do things completely differently. And the purpose, of course, is to bring costs down, to get rid of rare materials. Lithium is a problem still, with the mining process, etc. They already got rid of cobalt now, at most of the batteries, and so there is a lot of things going on. So to give you an example how that contributes to more sustainability, to more efficiency, for example, apart from solid-state batteries that I mentioned before, there could be lithium metal batteries. So that means you modify the anode material of the battery and replace the graphite that is on the anode also with lithium. That gives you a significantly more energy density, and that means more range. Or another exciting concept, for example, are aqueous batteries. So aqueous batteries are basically replacing the electrolyte with water-based electrolyte. And water-based means it's more environmental friendly. So that means hopefully in the future we will also see more materials that are in general a little bit more greener. So I think that's all good things that significantly contribute to a greener battery cell product design in general. If we move on to the production process, I strongly believe that it's all about advanced automation technologies, of course. So if we look at how lithium-ion batteries are made today, we are far away from really mastering the process, achieving the speeds that are needed to fulfill the high demand in the future. I mean, most of the battery clients that I have visited, we're talking scrap rates of 30%. 30%. That's a significant number. And if you compare that, for example, with standards in the automotive industry and other industries, that it's way too high. And this is exactly where you can move in with newer technologies. And it's also no surprise that data digitalization is going to play a very big role here. Artificial intelligence, machine learning, also utilizing cloud manufacturing technologies, those kind of things. I think that can really contribute to master some of those challenges here on the production process. And then, and then last but not least, in terms of the supply chain, I think that's a very promising technology that is actually coming up and is currently in the making. It's a so-called digital battery passport or digital product passport for batteries. If you're not familiar with what a digital battery passport is, it's basically a supply chain traceability system or an electronic exchange solution, where you can share information across the entire supply chain. And the big advantage, you can think of the system like a digital twin, a digital representation of the actual physical battery cell. And this digital representation contains and stores all the important information about the life cycle of the battery. So that means what materials went into the cell, where did that material come from, how much CO2 was generated throughout the production process. And I'm really talking about starting from the mine throughout refining and all the different process steps that were necessary to assemble that cell. To prove that there was no child labor involved, that's always a topic now. So if we consider where the raw materials are coming from. And many other things. I mean, those are just, important things to comply also with upcoming regulations from the European Union. But on the other hand, manufacturers can also benefit, to get a better insights. What is the status? What is the health of my product? And you can also utilize that information to further optimize the product and also the process. So those are, I think, very promising new technologies that can really help and contribute to more sustainability and more efficiency.
Thank you very much. It's really a broad overview. And actually, when you started talking, it was so positive. It's like, wow, no problems, no issues, no challenges, no. But then you made it really realistically adding something. And let's add a little bit more of challenges, because I would love to talk about costs, because transition always costs. And especially the initial cost can be quite high. So question for Matthias, like how to balance it out, the initial cost that go into a transition phase. So how to bring them down, let's say, and how to make those sustainable practices more efficient in the long term?
Well, bringing the transition cost down, I think is a futile approach, because we will not be really successful with all of the transition that we can say it's going to be cheap. It's never going to be cheap. But the question is it going to be a good investment? So does it all just need to be done and incentivized by the public hand? Or do we get private funds into that? You will always get private funds if there's a business case behind it. So, and on the one side, that needs governing bodies and regulators to give a long-term stability, but also on the other hand, this scouting of technologies, which is the right one before you scale it. And we talked a lot about electric mobility. And if we bring it to the point, I mean, hands down, electric mobility is the perfect solution for passenger cars in a heavily or moderately populated area. There are a lot of other applications. Think about trucking, non-road, off-road, where as of now, we pretty much see a pure battery electric solution might not be the ideal solution if we take a complete circular view on what it takes on a CO2 or on a carbon footprint. So we have the different phases, and electric mobility, I think the development, we've pretty much sorted and mastered that. And bringing a technology into the market, that's the first step. Now the question is, you brought it right, now we have the questions of scaling it, bringing the costs down. How do we deal with raw materials? How do we deal with the global environment behind that? But then also the third step is, once we have a big generation change, and we have a lot of these products in the field, how do we recycle them? Do we bring them in a circular economy so that we don't always need raw materials? So one of the next steps will be, battery electric is not going to bring us everywhere. So which are the other ones? If we have liquid energy carriers, they have significant advantages. How do we get them? How do we generate them? How do we make them sustainable? Is it going to be ammonia? Is it going to be H2? Is it going to be a fuel cell? Because a fuel cell is still a fuel cell hybrid, so you still have electric powertrain and you need a battery. Is it going to be in a combustion engine? So there are a lot of questions where we still need to spend this initial invest of mastering the technology to understand which one is superior, and then have the long-term visibility and stability to invest in that. And I think battery is the good example. Initially, whilst we only had a few cars in the field, we all thought there's going to be a handful of terafactories in the world, and cells are going to be a commodity, and we're all going to buy from the 5, 6, 7 suppliers. That is not the case. So obviously found out the big differentiator, both in cost but also in efficiency, at the moment is the cell. So a lot of people are investing into their own cell technology. We see the spawn up of a lot of startup companies, and that's a good sign. There is a long-term stability if you invest in a startup company, because that needs venture capital. So venture capitalists are interested to invest into these startups because there is a long-term vision to get money out of that. So if we want that, we need to have these different phases, incentivize the first phase, that the industry and the engineering can sort out the major technical flaws and issues and figure out what are the superior technologies for the near and mid future to come. And then we get money out of the private sector to help and scale it.
My takeaways from what you just said is like, okay, again, keep the technologies broad. Don't go just for one technology because it's like the right now, the most suitable one, but just keep it broad. And the one is what you also said, like you always get some funding when it makes sense also business-wise, not just technology-wise. No? So basically that's, and you know that because you mentioned venture capitalists, but actually what Rockwell Automation also does now, or actually every global company that is supporting startups, you invest in the ones that make sense also business-wise, not just sustainability-wise. No? So we are not in a romantic world, we just, it has to make sense in all of the areas, let's say, no? So business and technology and sustainability. No? So thank you very much for this really broad overview. And now the next question, let's get into this regulation field, etc. So you can make it positive, you can make it negative. Tell us all of your sorrows, let's say, no? So, and show us, let's say, all the regulations and let's say, regulations and government policies that you have to work through, let's say, do they help or do they hinder? Because we had at the beginning, we just mentioned like, okay, sometimes they help, they can be driving force, right? The bans that were mentioned in the beginning. How do you see that? And what is your wish list, let's say?
So I won't be able to go through all the regulation because otherwise we will have a very long broadcast today.
And boring one.
Well, maybe for some yes, for some not. The energy sector is rightly very regulated, and it is it also has a lot of political attention. No matter where you are, in Austria, in Europe, worldwide. And I think there are good reasons for that, because if you go back in history, you see that whenever there was sufficient supply of energy for low prices, then industry activity increased, and you can see that when you go back to the first and second industrial revolution, in time you see that that was always the case. So there is rightly a high attention on the energy sector and the functioning and the rightly function of the energy sector. In terms of regulation, is it hampering, is it hindering or driving this transition, this necessary transition? I think if we look at what happened in the near past, especially in terms of driving this net zero transition, you have this. You have the Paris Agreement at the COP21. You have different legislative acts on the European level. You have the European Green Deal. You have the Fit for 55 package. In the US, you have the Inflation Reduction Act. Those are all key instruments in order to tell stakeholders, tell the industry where public society, where politicians want to go. Right? What are the long-term targets, the long-term ambitions? They also tell you to a certain extent what activities will be supported financially wise, what activities, if you think of the EU taxonomy, for example, what activities will be more or less moved out of business activities, and you as a company, you can look at it and can say, well, is there a business case for me, or do I gradually shift my business activities to less carbon intensive activities? I think Matthias touched on the point that we are nowadays in a situation where often politics and regulation focuses on the how and not on the what. So I think that's actually some kind of issue we have, that if you tell companies, okay, we want to be climate neutral in 2040, 2050, then companies will actually move into this direction. But if you then tell companies, okay, you have to go there, but we tell you exactly how to do it, then it becomes a bit of a problem, because then what we see is that on the first cover, it's always said that we need a technology neutral approach, but we tell you which technology you are allowed to use and which not. And I think a very good example where it's actually working is the European emission trading system, where politics set out the goal on how fast to reduce CO2 emissions, and you can see that the companies that are that have to comply with the emission trading system, that they actually manage to gradually decrease their emissions. And there are several other cases where you have conflicting signals, where you say, well, politics regulation is rather hindering. If, for example, you think about current European sustainability reporting standards, you use the resources in companies to do documentation and reporting activities rather than actually work on the issues that you want to get solved. I think we are currently in this situation. We have in Europe European elections coming up. We will see if the European Green Deal will, or if the next Commission will actually continue the European Green Deal as it is currently existing, or if some changes will be made. And I think as companies, you have to make it work. You can complain about regulation, you can complain about the political regime. In the end, you have to make it work for you, and you have to live up to the challenge.
Interestingly, you mentioned like at least 3 issues, 3 challenges that are so misleading even, it's like, oh, okay, how to work with that? And in the end you say like, okay, actually it doesn't matter, you have to work with that. So complaining doesn't bring anything. So I don't envy you, and I think no one in the audience envy you also that you're working with that. So, but keep on going. So actually, and we mentioned also something like, okay, the technical challenges. We mentioned the cost efficiency. You mentioned like the what and the how, but there's also the why, the sustainability aspect, right? So the next question is actually for Christian, like how to balance that, let's say, the short-term profitability against the long-term sustainability. So how to do that?
So for me personally, my opinion is it's also a little bit a matter of a company's culture, a company's core values. So for example, if you're really serious as a company about sustainability, then I think you also have to put ESG, environmental, social and governance topics as one of the key metrics on how you define business success. So this is where it all starts, with proper sustainability targets. And then the next step is, of course, I strongly believe if you really invest into sustainability topics, if you really allocate resources to, let's say, environmental friendly initiatives in your company, then you can also make quick gains and get your return of investment very quickly. And in general, it's not a compromise, sustainability and profitability. For me personally, everything needs to go hand in hand. And there is benefits of doing that. And for example, if you take the manufacturing space as an example again, I already mentioned before quality in general, right? Not only battery production process, quality always matters. And we have, scrap reduction, we have energy reductions, we have, waste reduction in general. So those are all important topics that matter for every manufacturing plant, for every manufacturing facility. And if you really tackle those challenges, it will have immediately a positive impact on your business. That's clear, right? And at the same time, you will also achieve your long-term sustainability targets because it's also contributing to that.
You mentioned waste reduction. Let's make it a bit practical. I don't know if I'm challenging you too much now, but can you give us some numbers, let's say, like what happened in the last, 5 years for Rockwell Automation in the waste reduction? So do you have some numbers? Like approximately?
As I said, we're talking about the scrap rate of 30% here. And waste reduction, it really depends on the process. So I don't have a detailed figure now ready that I can present to you, but there is always gains, there is always improvements that you can make in that area. It's a never-ending story.
But actually, let's still continue to make it a bit more practical. Let's get into the case studies. Matthias, would you have some examples, let's say, for successful industrial energy transition? Any case that you can give? It can be from all kinds of fields that you work with. So.
Well, we spend a lot of time on the mobility sector. Maybe just a final example of that, because it's a little bit my past. If we just think about, it doesn't need to be boring, and sustainability doesn't need to not make business. And that's what you brought up to. And I think maybe Formula One might be a good example. And that already goes pretty much a decade back. So in 2014, a new engine or power unit regulation was introduced, making the system hybrid. And with this hybrid system, Formula One managed from one day to another to keep the same kind of format, same performance and lap times, and reduce fuel consumption, and by that also the CO2 emissions by 50%. So really cut it in half. And there was a lot of headwind saying the regulation won't work and nobody wants to look at it anymore. There will not be any spectators. It's one of the highest growing sports over the past few years. So it is very popular. And in all of that, we agreed we want to be net zero, 2040, 2050. And that's one aspect that is very important to the climate. The earlier, the better. But the second aspect that in this oversimplification we always neglect is how do we get there? How much do we still have as a cumulative impact on the environment until we get there? And by being very narrow-minded, solely looking in one direction, aren't we just stripping ourselves of the options where we can have a lot of quick wins to give a significant benefit in the short term? And if we move that over to the energy, and I think on the energy sector, we've now just we want more electric energy, but not only for mobility. We need it for industrial processes. We want it in food production, Central or Northern European topic. How do we deal with heating? A lot of that was on unsustainable fuels, no matter whether they're solid or liquid. Is it going to be heat pumps? How are we going to do all that? So there is a lot of future demand on a very big scale on electric energy. Where are we getting it from? Where are the grids? Do we need another energy carrier in between? And again, we've been, on the mobility side, it's a huge aspect not only to automotive mobility, but that's why we're also looking at aviation, at marine and railway. Because of this big innovation boom that we had in the electrification, specifically in the automotive industry in the last years, I think we've mastered now a few technologies that help us in these other industries as well. AVL as a company, we're spreading out into these, and also coming back to the original topic of this podcast or of this discussion is industrial energy. If we think it bigger, one of the projects that we're currently working on is a technology that we're doing now there based on solid oxide electrolyzers, where we massively could improve the efficiency of the entire system. So we need less primary energy, less electricity to transform it into a liquid carrier like H2.
Thank you very much for also this overview, and also that gives me hope, let's say, because it's a lot to do. And a lot to do means always a lot of business cases, a lot of potential. So therefore, really, really good.
But also in this, a lot of potential business cases that will fail.
Part of the game.
And whenever you're technology open, I think that's the real situation where we're currently in. We need to be technology open because we don't know what is the optimum for the future. Whenever you optimize, there are a lot of paths you will at least explore a certain extent to then shut it off and go in the right direction.
But actually, you know, like when you make your strategies for the future, no? So particularly with your background, no? So with the, let's say, economics, etc. So, I mean, you plan that in, right? I mean, you plan certain percentage for something that might happen, that might not go well, no? So therefore, that's all fine. So therefore, I'm still positive that it's going to be all right. So, and we continue to be very, very practical. And I would love also from you, Philipp, to hear some case studies, but on a certainly different topic, digitalization and usage of smart technologies, let's say, in the whole complex system of energy transition. So please put your focus on that.
Okay. So the energy sector is basically a very hard tech sector. So it's very capital intensive, you have long maturity timelines, and you always have the issue of how best to align technology, business cases, financial feasibility, and politics and regulation with each other. So now we have heard at the beginning, this whole transition needs a lot of investment. And although on a very general level, there is sufficient money in the markets and there is sufficient financial support for such initiatives, you have an increasing complexity in the system, and you cannot put human resources on it, but you need some smart algorithms, some artificial intelligence in order to make the system more efficient, the already existing system more efficient, and to empower it to handle the increasing complexities that come with this transition. For example, I think Christian touched on the issue of digital twins. That's, for example, one thing we usually apply when we, for example, project new power plants, etc. When we have hydro plants in our planning systems, we look at it, we project it, and before we actually then make the final decision on investment or on investments in those power plants, we have such digital solutions. I think what we also see is that, of course, you have, for example, what's a very critical issue is how to match supply and demand of renewable energy sources. And that applies to households, so in a very small scale, but it also applies for industrial players. Because what we see in the system is that usually on the weekends, you have often very lengthy periods of excess energy supply. So energy is basically for free. Sometimes you even get paid for using the energy because it's a sunny day, the wind is blowing, the PV plants, the wind farms, they are all producing. In addition, hydro plants are producing, but people are out of their offices. In the industrial factories, they are not producing. So what we see is come up with technologies or implement technologies that are already existing solutions that allow companies to actually shift the production from times of high electricity prices to low electricity prices, which then also carries along a financial benefit and a certain business case. We have, for example, here in Styria, we work together with a very renowned industrial player in terms of hydrogen. I think it was mentioned by Matthias, in terms of their ambition to go into the direction of green steel. So how do you manage the generation of green energy, then the transmission, and then, for example, the production of hydrogen or storage in order to use that energy at certain times. So those are all use cases we are working on, and yes, digital is here to stay, and it's, I think, very important in order to support the transition to become more sustainable, and in order to be more efficient in also the usage of capital and financing.
You actually, as the very first one, did something super exceptional here in this discussion. You mentioned for the first time in the whole round, human factor. We are in the times of transition, and we have to keep in mind that those are always people working on those transitions. So let me ask you, let's say, looking at the whole digitalization, smart technology usage, etc. So what kind of human skills will be in demand in the next, let's say, 10 years or something, you know? It's like, how can people prepare for that, what is coming, so that they are excited about it, not frightened?
Well, so in the past, we looked for classical jobs like technicians in order to work out in the field, in order to repair the grid, in order to install certain things. And currently, if I talk to our HR, we see that we are looking for data scientists, we are looking for artificial intelligence experts, we are heavily investing and looking for people into analytics, business analytics, in order to see also how, in order to have a better understanding on what, for example, energy generation supply will be in the next 24, 48, 72 hours, in order to better match supply and demand. So it completely changed, and yes, it's very difficult to get these personnel, these colleagues, because as you can imagine, not only the energy industry but also a lot of other companies are actively looking for these skills, and yes, especially here in Graz, in Styria, we have a lot of industrial players that are all looking for these graduates, and yes, it's a tough market.
Matthias smiled. I mean, you are competing for the same people in there.
STEM, science, technology, engineering, math. But I put it maybe a little bit differently. So what are we looking for? Be creative, be innovative, and don't be afraid. Tomorrow, I have no clue what tomorrow is going to be like, but I'm quite certain it's going to be different.
But is that important? I mean, how tomorrow will be? It will come anyway. So then just
That's
learn
why
to
I said,
adopt fast.
we need people that are not afraid to make a change.
And perhaps you can also look a little bit outside and talk to companies like Rockwell Automation to also maybe help you out on some of those topics.
I think that's a very important point. You don't, in the past, especially in the energy industry, companies tended to do everything by their own. And I think we have already entered, but we are even more entering into a time where collaboration, knowledge sharing is actually, knowledge sharing where possible, is actually becoming more and more important. When we talk about sustainability, sustainability reporting standards, EU taxonomy, etc., it's good to share insights, best practices, expertise. Not everyone needs to develop the wheel on its own.
But that's actually why we are sitting here and why such amazing formats like Creators Lounge exist. No? So, because it's all about collaboration, it's all about innovation spirit, it's all about working together. So, and the next topic is collaboration for me. So we have an amazing expert actually on collaboration here. And Christian, what do you see, which factors do we need to collaborate together exactly on this topic of industrial energy transition? And what do you see as most important so to make those collaborations work efficiently? Yep.
So Philipp made a great transition to this topic. Basically, as you know from previous discussions, I'm a big fan, I'm a big advocate of collaboration in general. And I would say, collaboration is really of essence for everything that we do. And if I talk about collaboration, I'm not only talking about collaboration within, a company, within an industry. I'm really talking about the broader picture, even collaborating with governmental bodies, for example. So because I can take, for example, one specific case here. I mean, if the industry, for example, collaborates also very closely with governmental bodies, we can start or we can create or maintain a healthy balance between, still having a profitable business and at the same time achieving the long-term sustainability targets. So we are going on a realistic growth path, if you want so, together. And for me personally, again, the Digital Better Passport initiative is a prime example of how this collaboration actually worked out. Because at the beginning, a couple of years ago, the European Union came up with this new draft of this new Digital Better Passport regulation. And at the same time, basically, industry experts came together to form associations, to form working groups, sitting at the same table and discussing exactly, okay, there is this new draft, those are the ambitions, those are the goals that are coming up to us. How are we going to solve those issues? How are we going to actually practically implement all of those things? Including timelines, including pilots, who is going to do what. So really sharing the responsibility amongst all the different members. It's not a single player game here. Mm-hmm. If you really want to be serious about sustainability and achieving the objectives, then it's really a bigger gameplay. And those working groups again had a word into the work what the European Union did into the governmental bodies. And I can even say that in terms of the Digital Battery Passport initiative, the industry 2-3 years ago was even ahead of the legislation and of the regulation of the new one. So I mean the Battery Passport acts into force 2027 onwards, and for EV batteries you even have to do some carbon footprint declarations basically now 2024. But that's actually a really good example of how that actually worked out. And I mean, as you rightly said, in terms of collaboration, it's a very good idea. You know, if we talk about energy transition in general, we all agree that this is a really risky business, and this is, I would say, very capex intensive. And for a single company, that could be really a problematic situation if you fail with one of those big initiatives. And therefore, we are also seeing at the moment, that's also no surprise, a lot of new joint ventures formed, a lot of new partnership agreements announced. We are also doing the same. And it's just for the matter of, you know, working together, cooperating, defining the future standards of the industry, and also basically co-investing together, and eventually then sharing the risk, right, and de-risking a little bit the situation.
Let's stay for the last round of the question in the topic of collaboration. And then we will have also some questions from the audience that I just got now. And actually, I would love to ask, because you are like big players, you know, like AVL, Rockwell Automation, etc. So like, yes, you are screening also for startups that you collaborate with, etc. But still, it's a different story if you collaborate with big ones or if you collaborate with a startup. So, Matthias, a question for you now, let's say on collaboration, like, how to do that differently with big players to make it successful? Is there any difference?
No, it is a massive difference. If you take a look at a small player, you look at them as either their technology or them as a team, where we would be the big ones to help them scale and include it into a bigger technology. So that's already still a long way to go. If we partner with big partners, and I think one of them publicly available, a recent bigger partnership was with Microsoft. There we see a more immediate benefit because we already know what we want to do together, and both parties know how to do it. And that the road to that, the whole becomes more than the sum of its parts, is just so immediate. And we need these partnerships with the smaller ones for our future growth, but also for the immediate effects with bigger partners where we collaborate together. And they are also circling back to where does the human factor play in? And we want to be we need to be very, very resource conservative and must not ignore that the human factor, human labor, is one of our most precious resources. So where we put real engineering ingenuity into the game, we should select quite carefully. Therefore, we need the digitalization, we need the automation, we need machine learning to do a lot of tasks. There's and we've just discussed today, how many different aspects need improvement. Time is of the essence because we all feel this urgency that we need to move to net zero rather sooner than later. So being quite conservative with the human resource is very important. One solution to get more done with the people that we have at hand is doing more digitalization and automation and machine learning, and the other part is partnering.
Mm-hmm. And actually, as you said, like we need those technologies, we need those machine learning, et cetera, et cetera. And once again, we need the people again who can use that all. So coming back to what we just started, let's say, mentioning. And yeah, we continue with collaboration, but your collaboration partners look completely different. I mean, those can be like big industrial customers, those can be governments, et cetera, et cetera. So therefore, just choose, let's say, your collaboration partner you want to mention. And say like, okay, what does make a collaboration successful that we can also take as a learning from your experience?
So of course we work together with startups, but as you rightly mentioned, we feel more comfortable working together with other companies of same size, with more or less the same approach, the same history. We are still working always on a functioning and working system. So whatever we do, whatever we introduce, whatever technology asset, whatever we actually do, we still have to make sure that it's not affecting the functioning of a running system. We often say we are working on an open heart surgery, and that's why yes, we are working together with startups, but we are a bit hesitant when it comes to introducing new technologies which have not been tested before. So our typical partners would be companies as AVL or other players that we have already worked together with. I think when it comes to collaboration, it's you should agree on what you want to achieve with each other. It must be clear who is bringing what to the table, and you should more or less have one common goal where you want to work towards too, right? Ideally, you match skills and competencies together. When we collaborate, often we do it, for example, in terms of renewable energy generation. We usually collaborate, have partnerships with other energy providers where we co-invest into certain projects in order to split the risk, to split the financial burden, to not use all our financial firepower on one project, but to be able to move into other projects. We are, of course, also considering moving abroad. We are not only active in Styria, but also abroad in other countries. So whenever we enter a new market, we usually want to do that in partnership with a local player because they understand better local regulation, local politics, local stakeholder needs. We partner together with other companies in terms of e-mobility. We are building public charging infrastructure in Austria. We don't do it alone. We do it with partners, with technology partners also. So I think there are a lot of partnerships we do, and I don't think that there is one key specific issue where you say this one is it, and then the collaborations will work. But I think it has to do with often is this issue of importance for me as a company, and is it also of importance for our partners? And if both sides say it's of key importance, then normally you have the attention there, and then it normally goes into the right direction.
Yeah, thank you very much. Now we close this topic of collaboration, or at least so far. Let's see how the question from the audience look like. So there's not written like to who it might address, so therefore just pick a question if you feel, let's say, that you can answer that. So do you see new ecosystem emerging and playing a significant role? Who wants to take that one?
Well, at the moment, for a lot of we have seen new ecosystems evolving. And I think electric mobility is one of this, and we have numerous there. But if we take a few further ahead on the track, the evolving ecosystems are still a little bit in the air, as long as we don't know which are the technologies that we need to scale. Because what does an ecosystem mean? I mean, we have ecosystems around innovation and around partnership. And then again, in this field, it depends on what you're looking for. Because if you have ecosystems partnering with bigger partners, you are slow, because both are slow, but you have the level of maturity. That's the big advantage. Mm-hmm. So if you have multiple technologies that you can combine immediately, you're much faster to the market. Whilst the ecosystems around startups and innovators, they are so fast and so innovative, but they lack the maturity. Mm-hmm. So if you're going into very early technology development, these might be a better ecosystem. And the ecosystems that we currently have, where we are quite active, is specifically around the partnering in this technology openness, the scouting. We're not quite sure which will be the right direction to go. So we need to be open and keep our eyes open, because a lot of people in other industries have brilliant ideas that we might just adopt for the ones that we're working in.
Mm-hmm. I perhaps have a slightly different approach here of you on the thing. So if I look at the manufacturing space again, So what we call a manufacturing ecosystem are basically all the suppliers that deliver equipment into those plants and realize a certain project, right? And in particular, coming back to e-mobility and coming back to the battery space, we have seen in particular at the beginning that there were a lot of different gaps because traditionally it was automotive companies that tried to realize those different processes, and they quickly figured out, oh wow, there is a lot of know-how missing. There is a lot of things that we cannot really realize. There is much higher speeds. There is a lot of motion going on, and all of a sudden we also have to deal with hybrid processes. So that means automotive is more discrete assembly. So this is what those companies actually do good: assembly stuff, material handling. But in battery, it's a completely different world, right? And all of a sudden, and this was also a little bit our, let's say, responsibility here, we are a multi-industry company. I have talked only about automotive today, right? Because I'm the automotive guy, I'm part of the Rockwell industry team from automotive. But of course, we cover any other industry that you can imagine. And that gives us the beauty. If we realize, okay, there is a problem, that there is, some missing players in the ecosystem of our customers, then we proactively suggest, hey, why don't you look, for example, at company ABZ, from food and bev, from pharma, from print and web, they are not doing batteries today. But by the way, the process almost looks identical. It's high-speed applications, it's roll-to-roll, roll-to-cut applications, those kind of things. And then we help those companies transition successfully over to, we also proactively invest and try to help our partners move into battery. And we have now built up, a handful or even 2 handful of really good partners that have never done battery before and are now significant players delivering into all kinds of different startup companies here in gigafactories in Europe.
And actually, those kind of successful stories that happened so many times that you started with one industry and actually you transitioned completely to different direction. That's even more successful.
Yep.
Yeah. The next question is, it was mentioned in the discussion, yes, several times, I can confirm that the transition to sustainable energy needs to make sense. It was economically and it was technically. No? So what are some practical steps the industry can take, so actively?
Well, I could just perhaps summarize again of what I said before. So for me in the manufacturing space, sustainability is not a separated topic anymore, I would say. People see this sometimes at this pink elephant that is above. But in fact, if you really tackle the standard challenges, as I said, quality, reducing energy consumption, reducing water consumption, reducing in general the entire industrial energy that is being used, to produce something, to manufacture something. If you tackle that, with advanced technologies, then it's basically goes hand in hand. That it's not a question anymore whether it's profitable or not, basically. Mm-hmm. So that's my take here.
Well, I think the answer lies within the question, to make sense. And to make sense is, reaching out as an industry with our capabilities to do what-if scenarios and to give an insight what the future might look like for regulating bodies and politicians, governing bodies, to say, please don't jump to premature conclusions, have an open dialogue with us. What's up in our mind? What's up in your mind? Let's do a study on this. Let's make sense before we jump to conclusions and put it into regulations that might be hindering, as you were mentioning before.
Would you like to add something? Because you have neutrality when it comes to technology and you are deeply in the economics. So that's your field now from the background. So would you like to add something?
I mean, as an energy company, the decision into where to invest to, in what generation technologies, this decision has been taken a long time ago. So it's currently under the current situation and under the current legislative framework, it's not feasible to invest into carbon-intensive technologies. So you invest into PV, you invest into wind, you invest into hydrogen. Of course, then you have to think about you need to transport the energy that you produce in decentralized plants from point A to point B. So you need the grid. You need to empower the grid, the existing grid. You have to maybe also build new grid infrastructure. You have to think about hydrogen, for example, etc., the production. So I think it's a very clear decision already that you go there. What you have to, what's often sometimes critical is how to match technology, business cases, and politics and regulation, right? And here you have sometimes uncertainties because regulation and political regimes they change. You have also difficulties that you have long permitting times in order to bring to plan and project infrastructure assets, and then also have them have the permissions to actually build them and plug it into the grid. So these are some obstacles, but the general intention, the objective to go into less carbon intensive technologies. This decision has been made.
We have some more questions and from our live audience. So who wants to ask something? And if you have somebody particular you want to address, please mention that.
Thank you. Good morning, Helmut Janko. It's very interesting to see that the transition is already working because the participants today are coming from Christian mobility, mostly driven, Matthias mobility and beyond, also energy solution, industrial energy solutions, and we have energy, not the typical oil and gas participants, so it's working. So my question to you in regard of collaboration is, what do you think the different industry can learn from each other? Is there anything what you can already tell us about that? Philipp, you mentioned digital twin as maybe a typical example, yeah, which could also be something which could shared very easy or learned from each other.
So this if I can just comment on this for now. So this cross-industry collaboration is extremely valuable in my opinion. And as I described before, we do that all the time. So we really utilize, all our different resources that we have distributed to gather as much information as possible, and also trying to transfer that from one industry to the other. So for example, I have also talked a lot about digital battery-based products today. In fact, this is something that other industries have been doing for decades. It's a serialization solution, basically, supply chain traceability solutions that are standard in pharma and life science, for example. If you manufacture medicines, you want to know exactly what goes into those pills, right? So it's just a matter of how to transferring that knowledge, how to transfer and modify that a little bit for our purpose that we specifically have in this industry. So it's of tremendous importance, yes, and we can learn a lot by sharing that information also.
I mean, on that, the obvious thing that jumps to mind is always technology. Technology in our products that we can learn from other people's to further improve our own products, and in the way how we are developing, producing, and circulating these products around. But the thing I think where we can learn even more, and that's also a completely different transition, is how we commercialize our products. Because automotive industry, where we're mainly coming from in the past, you build a product, you sold a product, and that was the majority. Are there other revenue streams? Is there a pay-per-use scheme? And I mean, just how you deal with energy, your commercial model to the end customer is so much more different than ours, but how can we learn from that? I think that's the next innovation where we can even learn more from other industries that we're partnering with.
So together with the Styrian chapter of Federation of Austrian Industries, and the top 22 energy intensive industry players in Styria, we just recently published a study we conducted the last year, in order to, which is called Master Plan Green Energy, which in essence was coming together and to look at it in the terms of collaboration, in the sense that each and every industry player more or less showed us the plans, their plans in order to decarbonize. Because they said, okay, we want to be carbon neutral by 2040, and in order to reach that goal, we want to electrify our current processes, our current factories by the time by 2030, 2035, etc. Our individual energy demand will increase by megawatts. And we did that, and I think it was very, very important to do that because in order to have companies, and AVL was one of those companies that participated, in order to have companies reach their own individual targets, you need infrastructure. You need the empowering infrastructure. You need the energy grids. You need the generation plants in order to allow the company-specific transition in order to become more sustainable. And also you need certain conditions. You need, for example, the affordability of energy. You need, for example, shorter permitting periods, etc. And I think the study we published, it was well received by local politicians, but by many other stakeholders, public stakeholders as well. I think it was a very good example of a fruitful collaboration, yes, and working together, learning from the needs and the limitations of other companies, where they want to go, what they are currently already doing, and how best one can work together in order to reach one common goal.
Do we have more questions from the live audience? Okay, one more.
Hi, my name is Anna Wambe. I have a specific question about green hydrogen. So there's a lot of commentators in the industry that believe that the biggest game changer in industrial energy transition will not be electrification, but actually green hydrogen. What do you think about that? Where do you see the green hydrogen trend going? And coupled to that question, one of the biggest inhibitors of green hydrogen entering, let's say, also the mainstream market, but also, for instance, startups and innovators picking up green hydrogen technologies, is that the price of producing hydrogen is yet very high. So it's extremely interesting to hear that AVL is actually working on electrolyzers to bring down the energy cost, to eventually also bring the cost down. By when do you estimate that we will have commercially viable green hydrogen on the market to go mainstream? And to Philipp from Energie Steiermark, does Energie Steiermark also plan to venture out into the green hydrogen, possibly produce green hydrogen in Styria or elsewhere?
So, if you mind. So Energie Steiermark is already in the field of green hydrogen. We already have a small plant in the south of Styria near Gabersdorf, where we have, I think, 1 megawatt electrolyzer plant there. We are currently also in projects of building larger plants for our own usage, for industry players in Styria, but also for coping or better managing excess energy provisions supply into the grid. So electrolyzers in terms of grids, or with the aim of ensuring grid stability. We believe that it's a topic that's here to stay. In this study which I mentioned, we also looked at the provision of green hydrogen in Styria. There we saw from the answers we received from all the participants, that in the first step, companies move into the direction of electrification of current processes where possible. And in the second step, and the second step would be more or less between 2035, 2040, and then companies move into the field of actually really using green hydrogen in numbers in their own production facilities. I think when it comes to green hydrogen, you have two issues. First of all, you need the renewable energy, which is currently often in rather short supply in Europe. So we are talking, when we talk about green hydrogen on a large scale, we normally talk about importing green hydrogen from other world places. We touched on the issue of partnerships. So you in the media you regularly read from partnerships that have been made in order to carry, to transport, to pipe green hydrogen from maybe the northern shores of Africa to Europe. You have certain corridors which are planned. You have one south corridor which actually is planned from reaching from Tunisia over Italy to Austria and Germany in order to pipe and to deliver green hydrogen. The other thing is at what cost, and currently cost and supply are not competitive or not given. You have hydrogen auctions. You had one hydrogen auction on a European level just recently, and you have now Hydrogen Legislation Act, which is currently discussed in the Austrian Parliament, which intends to have a national hydrogen auction, a first one at the end of this year, in order to provide financial support in order to make these projects financial feasible. Long story short, hydrogen is definitely a very hot topic. Sometimes it's a bit hyped, but we believe in it, and yes, we are also active in that field.
So to the first part of your question, is it the next big innovation driver? When it comes to energy transformation, it's for sure one of those. Because electrification, on the innovation side, we've pretty much sorted out the big questions. I mean, we now have powertrain efficiency significantly north of 90%. How much money do you still want to spend there, and what's the reward that you get out of that? The efficiencies that we have with producing hydrogen, or even then retransforming it into electricity again, there we still have big gains to make. So that is the energy. That is the significant innovation that is going to come. But to the second part of your question, when will it be commercially viable? And I mean, I think we're approaching that now from two sides of the story. Sorting out the issues on the technical side means we will know which type of technology or which details in the technology we then need to scale. When we scale it, it will become cheaper. The price to create it will be more cheaper. It will be quite commercially attractive, I think, in the near future to start investing into hydrogen plants. I will see that coming in the next 5 to 10 years, that we get a lot of plants. Seeing where currently the development is, at the rate of the development, I think we are on the doorstep of major breakthroughs in the technology there in the next 2 to 3 years. So that is the first step. The other step to make it commercially viable is you can make it cheaper, but I see a big price increase on the alternatives. If we don't start, if we walk away from banning technologies, but just de-incentivizing these technologies, you will meet in the middle, and suddenly there will be a break even where it will be also commercially viable then to the end user, maybe industry or even the consumer.
So I agree with everything that you said. You brought it up 2 times today, banning technologies. So in my opinion, or my understanding is here, also in particular looking at what the European Union is, we are not banning technologies. You can use any technology as long as you produce 0 emissions. So you can use an internal combustion engine if there is no emissions coming out behind the pipe. That's the big difference. So we are not banning the internal combustion engine. If you can prove by using any other technology, for example, hydrogen and fuel cells or whatsoever, yes, or you can fuel, with alternative fuels, internal combustion. It's all good. And to your question in terms of mobility, for me the future is pretty much clear. And also, talking with many different clients in the industry. For passenger cars and vehicles, the ones that we drive or will drive daily, I don't see a future for hydrogen. That's the reality. So it's gonna be fully. It's voted. All the investments are going to fully battery-powered vehicles for passenger cars. Hydrogen still will be around for sure. There is a place. It's also a great technology. It will contribute to achieving those sustainability goals. But we, in particular, in this mobility bubble here, we see it more as a niche application. And honestly, initially the idea was more or less okay, where we have issues with long-haul vehicles, trucks and buses, etc., that really need to go long distances, and where charging might be an issue, etc. Those could be, for example, applications where hydrogen could make sense, and also fuel cells and all those kind of things. But at the end of the day, it will never be as efficient as a fully battery-powered vehicle. And this is also the reason why we are seeing the majority of all major truck brands also fully investing and even making their own batteries to fully battery-power their vehicles, their trucks. Of course, they're having side streams, still doing fuel cells, still doing hydrogen, but even the trucks going 1,000 kilometers and more are all fully battery powered. So in the mobility, I don't see a big future for hydrogen, to be honest. It's gonna more stay a niche vehicle.
If you limit your thinking in mobility for on-road mobility, certain valid arguments, but if you think about marine and aviation, there are physically, naturally limitations to pure battery electric mobility.
Absolutely.
But I'm quite certain we will get to know the real answer if we read the comment section in a day from now.
Exactly.
On the online version.
That's just my view for now. In the foreseeable future, let's say, I don't see hydrogen happening in vehicles and in the mobility space. At least.
Passenger car, yes.
Passenger cars, and even
it will be big.
And trucks. It's gonna be trucks, buses, construction vehicles, those kind of things. It's a mix. So the majority is also more investing in the fully battery-powered vehicles. Because think about the construction business, for example. I mean, high-performing batteries do not really matter in that application. It's completely different compared to passenger cars, for example. Also, charging time in most cases do not matter that much. So you can design the batteries also a little bit differently to achieve higher cycle times and all those kind of things. And in general, as you said, in terms of technology, we're still not on par in terms of efficiency. These energy transitions, from fuel cell, electricity, etc., powering an electric motor, it's the powertrain is still too complex.
You know what is brilliant? I mean, after 1 hour of discussion, and I'm serving that now, so a little bit more neutrally. Now, after 1 hour, they start to discuss truly, right? So, I mean, in a perfect world, I would say like, okay, heated discussion, keep on going. We continue for 1 hour more. We would have to close. But that's not the end yet, because I would love to introduce again Sebastian and to wrap up a little bit of the session, let's say. So what do you take away from this discussion now?
Thank you, first of all, to the panelists. It was really fruitful and open discussion, and I think this is exactly what Creators Lounge should be all about. So open discussions, exchange and collaboration. That's what we directly achieved today. So my takes from here is, as an innovator, it was great because we've seen a lot of opportunities and a lot of challenges and not yet so many solutions how to tackle those many things that are ahead of us. And that's exactly where and why innovation plays such a huge role. And the most important, and the panelists said that often, and you, maybe it was a little bit staged, no it wasn't, but you moderated it nicely there, so that collaboration could be and should be the key and the answer to come up with the right solutions for those many opportunities, but also for those potential problems that we are facing in all industries. And this is, I think, the most important topic, and my takeaway is we are not alone in our industry. All industries face comparable challenges, face also comparable opportunities. And the beauty is, if we are able to collaboratively solve them, we may be faster, more efficient, and it would help us to really fulfill what we do need. And at AVL, we say we owe it to the planet.
Actually, being an engineer myself, let's say, do you know engineers that love solutions? They love problems, they love challenges. They are a bit different, so like, but now in quite unusual question, I mean, we have here like AVL, we have Energy Steiermark, we have Rockwell Automation, particularly those two like big players, like how unusual is that for Creators Lounge to bring people that are from the same industry, that are even competitors in some fields, and to make them discuss and collaborate, etc. So how brave is that, actually? We have to acknowledge that, right? So why do you do that, and what kind of other programs you have, let's say, in that space?
So a very short glimpse on where we come from, and it was also part of the panel and the discussion before. We did a lot of work with startups in our early stage of our program and of our being at AVL. We loved collaborating with smaller and companies who are faster, bringing up new technologies, new things like startups do. But we realized, and Matthias mentioned that, we realized that at some point we also should foster partnerships with big corporates and companies, which we always have done because we were serving them as our customers, we had them as our suppliers, but making them strategic partners and some special and specific needs opened up opportunities that we haven't had before in those relations, like, as I said, as customer relations or supplier relations. But that's not enough, because where we are already mastering partnerships is in direct partnerships between ourselves and one partner. But what we've seen is that each and every partnership itself is a lot to manage, to think about common challenges, common opportunities, and aligning ourselves. But we believe there is more to that. And there is the opportunity that we can, and that's why we inaugurated a program that we call CoLab, a programmatic way how many partners from different industries are able to engage and to collaborate to really do exactly what we are seeing in those panels. And to answer your question on why we bring people together in communication, no, we don't just bring them people in communication and panels. We want to and do bring them together also in actually finding common challenges, finding common goals, aligning, and then doing and making use cases and solving use cases in our program. So if you're interested, join in on creators-expedition.com. Look out for the CoLab and find more information there.
Thank you very much. Thank you for all the information, for creating that spirit so that it can live and foster, let's say, collaboration spirit and innovation. So thank you also for our guest. Thank you for the audience live, for the digital audience, and also for everyone who is going to listen to that in the recorded version. And I would love to end that with something personal, so that everyone takes something personal from this discussion. Whoever had a phase of transition in your life that changed you, that changed your trajectory? Who had that? Like, I don't know, going from school, let's say, to being a student, going from being a student to a working life, or let's say going from one company to another, or let's say being single, being in a relationship, or whatever it comes to your mind, or becoming a parent, whatever. Whoever had this kind of transition in life? I mean, I did. So whoever had this transition phase that was maybe challenging, that was maybe painful, that was maybe uncertain. Have you made it through it? So yes. So therefore, we learn also from this transition phase. We learn from pain. We learn from that. And who would ever say, like, I don't want to have that experience anymore? Who would, if you could, let's say, who would trade that against not having had this experience? I wouldn't. Hands down. So take this message with you. Don't be afraid that the time of transition is there. It is there, and it is here to stay. Have a nice day.